All right, so we are doing what I call the normal word problems today. You absolutely have to have watched the video that taught you how to use this chart. Gave you some lecture notes, but most of the video was how to go forwards and backwards on this chart. So if this chart does not look familiar to you, you are not ready to watch this current video. You have to go to the one from the day before. So also have this out. I'm going to make a few comments before we get into the video for today. But let's see. So part of the previous video was also to remind you about the shorthand notation. When you see squiggle capital N, mu, comma, sigma, this is across the board convention. This is not my shorthand notation. What comes before the comma is the mean. What comes after the comma is the standard deviation. You're going to continue to see that notation the rest of the semester. On the previous video, I had briefly mentioned this, what I call a little flow chart. X represents the variable, Z is the Z-scores to try to standardize it down. This is the exact same Z-score from test 1, the exact same formula. Then the areas or the probability, we're going forwards and backwards. Let me add in just a little bit more, trying to remind you. The video before this one only had you practice how to do that part. If you had a Z-score, how to look up the area. Remember, area is the same thing as probability. Or if you had area, how to get the Z-score. There was no context to that though, right? It was literally just how to use this piece of paper. So now today we're doing a video where we're actually bringing in the real variable. So this is the actual variable, the context, a real word problem that has meaning to us, right? So it's always a two-step process. You never get to go straight from the variable to an area, so it's really important to make sure you're not skipping a step. Again, I'll make a few more comments about this piece of paper, but every single semester, this seems to be an issue. There is handout 9. You should have already printed it. Kind of looks like that, okay? There's a lot on handout 9. Only some of it is test 2 material. The rest of it is test 3 material. This is your precise homework from handout 9 for test 2. 3A, 4A, 5A, 9 through 16, omit 13. Do not tell yourself, oh, I'm going to be a better student and go do 3, B, and C, or I'm going to go do number 7. That is not test 2 material. I have not taught you how to do that. This homework is actually listed on the homework file that really the book users use. But if you forgot what I wrote down here, I even loaded it on the last page of the lecture notes that go with today's lecture. It's also on the homework sheet. One other thing, because some of you are super organized, the last page of these lecture notes said that we were going to do some problems from handout 9. I scratched that out for today. This video is going to be long enough. I will do more problems during the review video. But you should go do all of these yourself. Remember, I have an answer key, worked out solutions. Use those to help you do these problems if you get stuck. Then if the answer key is not helping, and after you struggle and try to process it, then of course come to me in office hours. All right, let me remind you a few of the highlights from the previous video. So this is one of the few times I definitely go old school. In Math 220, I do not teach you how to do the shortcuts on your TI-83 because I'm pretty sure I could teach a 10-year-old how to do it. They could get numbers, but they have no clue what those numbers mean. So I'm hoping, of course that's my hope, right, that from constantly looking at the picture up here, it helps highlight what are these areas. So this is what the normal distribution looks like. This is the standard normal, the Z, okay? The mean is 0, standard deviation of 1. This is really just the empirical rule, kind of like on steroids, right? After this video, you are never using the empirical rule again. That was an approximate based off of just experience. We now have the results of calculus. Much, much, much more precise, right? We don't do calculus, so someone did the calculus for us and gave us the areas to 4 decimal places. See the body of the chart here? I always said I was going to be waving to you. All these 4-digit decimals are the areas. Along the frame are the z-scores to the hundredths spot. Now it makes sense, these are negative z-scores. These are positive z-scores, right? We learned that from test 1 material. If you're below the mean, you have a negative z-score. If you're above the mean, you have a positive z-score. Down this way is giving you the ones place and the tenths place. The hundredths place is up there, okay? So the frame are the z-scores, areas in the middle are the 4 decimal. All right, let's get started. Okay. I don't know if this is good news or bad news. This video is probably one of the most critical videos. It not only prepares you, of course, for test 2, but the exact same procedures and skills that you learn in this video are also on test 3. So this is definitely not a topic that you can say, oh, it's just a little bit of test 2, who cares? It continues throughout the whole semester. All right, I totally made up a problem here. Just maybe, I don't know if I'm talking about a Honda, a Toyota, it doesn't matter. A certain car, its miles per gallon is normally distributed. The mean is 24, standard deviation is 6, okay? I just did the shorthand notation. If you actually look at my very precise lecture notes, you'll see I used words. Miles per gallon, mean is 24, standard deviation is 6, but then I shortened it up into the shorthand notation. Okay. Part A. What percent of cars get less than 15? Now, I do not require that you draw a picture on a test, even if we're in person. But every single time I'm going to draw a picture to, again, try to help you with the underlying concepts of what are we doing, and there's also some checks and balances you'll get from it. So, quick little sketch. Mean is 24. 15 would have to be down there somewhere, right? And this problem asked less. So there's the picture. What does this picture do for me? It does 2 things for me immediately before I ever go further. It tells me, well, let me back up for a second. See how it said what percent? It's actually asking you for the area. See how it gave you the 15 miles per gallon? It gave you the X value. So this is an example of X to Z to A. It gave me the X and it's asking for the area. So back over here, this is an X value, right? From looking at this picture, I immediately know that in a second, when I calculate the Z-score, I better have a negative Z-score. Meaning, if you hit numbers wrong on your calculator, you're not doing the right formula, and you don't get a negative Z-score, you need to immediately stop and say, I've done something wrong. I also can see that my final answer, what percent, has to be less than 50%, right? Because the middle of this is 50%. I also am a fan of algebra, so I'm going to, P parenthesis means what's the probability? That X is less than 15. I'm just rewording the question that was asked, right? Now, I can't work with X's. I can only work with Z's. That was discussed in the last video. How do I get Z's? I'm just going to stick this up here because you should know this formula from test 1. Remember, Z equals X minus mu over sigma? So, here's my X, right? Minus the mean divided by standard deviation. You'll always hear me say, you subtract off the mean, divide by standard deviation. Stick that into your calculator. You will get negative 1.5. Yeah, I knew I was supposed to have negative. You're now going to pick up the z-chart. Again, throughout this, I would highly recommend you pause the video, go look it up for yourself, see if you find it, then restart the video, right? If we're in the classroom, I'd give you a minute of silence to do it, but we don't need to do that on a video. So you're looking up negative 1.5, and the first spot is negative 1.50. So I see the number 0.0668, or 6.68%. I never care about the form, right? But if you give it to me in percent form, you have to use the percent sign. That's the easiest problem we could start with. The reason why I say it's easy, because it's good for you to know if you have an easy problem or a hard problem. Going forwards is normally easier than going backwards, and that this was a less than. Remember, that's what these pictures, and that's what I probably said 10 times on the last video, that this chart gives you less than areas. Well, that's exactly what I wanted, so I'm done. I don't have to do anything different. I can erase that. We all have it written down. Let's go on to part B. There's like 6 parts to this. The last question I said, what percent of cars? I could say, what is the probability? It's all the same thing, right? What is the probability a car gets between 20 and 30 miles per gallon? On the last video, I taught you how to do the stuck in between problems. Let me get a quick picture. All right, the mean's 24. I don't know where 20 is. It's somewhere over there. I don't know where 30 is. It's somewhere up there. This is what they want from me, right? Now, this is one of the few pictures that I will be the first one to tell you hold on just a moment. I will be the first one to tell you that the picture's not that helpful. I really don't know if the final answer is going to be less than 50% or greater than 50%. But at least the picture tells me when I get a z-score here, better be negative. If I get a z-score there, better be positive. Okay? All right, so gonna kind of remind myself what it asked. It asked 20 less than x, because I'm at the x level, right? Maybe I should do that one more time. It gave me the x's. Granted, it gave me 2 of them. We'll figure out what to do with that. When it said, what's the probability, it's asking me for the A or the area. All right, so I got to get 2 z-scores now. That's okay. Subtract off the mean, divide by standard deviation. Subtract off the mean, divide by standard deviation. This is negative 0.66666 repeating to 2 decimal places. It's negative 0.67. Now, at this point, some of you might say, oh, I thought she wanted 4 decimal places for numbers less than 1. But remember, this is the only thing that I can use. This is the limitation of the chart. I have to round my z-scores to the 100th spot because that's the only as precise as I can be on this chart. So I didn't round it to 2 decimal places because of my own opinion. This chart requires that I round my z-scores to 2 decimal places. Okay, so on the stuck in between, I taught you the trick on the last video, and I also supported why the trick works. Remember how it works. You're going to look up the z-score of 1. So when you look up a z-score of 1, 1.00, 0.8413. Then you're going to look up a z-score of negative 0.67. Negative 0.67 is down here somewhere, right? You should get 0.2514 and you subtract those. That's the answer. I want to make some comments, and my comments are always trying to point out the mistakes that students make on my test. One of the most common mistakes here is to actually subtract the z-scores. That has no meaning. That is completely wrong. You're not going to do 1 minus 0.7 and get something and then go look that up. That's completely wrong. The last video taught you that when you get your 2 z-scores, you look up the areas associated with the z-scores, and then you subtract the areas. You never get to subtract z-scores. You don't get to subtract x's, only areas. Another, then usually a student will ask me, well, what about if you reverse the order, right? Well, think about it. If you do this guy minus that guy, you're going to have a negative area, which is impossible. But the magnitude's the same, so just don't write down the negative. Like, look, 10 minus 4 is 6. 4 minus 10 is negative 6. And you're like, oh, darn, I subtracted it in the wrong way. Just don't write down the 6, right? So, okay. Let's go on to part C. What's the probability a car gets more than 48 miles per gallon? I have picked these questions to try to hit all the different things I know you're going to see on handout 9. I'm going to take a sip of my coffee. All right. So let's get a quick picture. 24 is in the middle. I don't know where 48 is. It's up there somewhere, right? And it wants more than. All right, there's my quick picture. This picture tells me I better have a positive z-score in just a minute. The picture also tells me I should have a very small final answer, right? Definitely less than 50%, but probably a whole lot smaller than that. This, part C here, is critical that you draw a picture, because I'm going to point out the most common mistake that students make. The problem is, most students just see the 48. They start calculating z-scores. Let me get more organized than that. The whole time, I'm staying extremely organized. I'm reminding myself it asks greater than. I have a picture reminding me it's greater than. Why do I care? You'll see in a second. Let's get our z-score, subtract off the mean, divide by standard deviation. This is z greater than z greater than 4. Huh, okay. Well, let's see what we can do with it. I'm going to approach this 2 different ways. If you don't like the first way, keep listening. When you go to this chart, well, golly, 4 is not on this chart. The largest I can look up is 3.89. The smallest I can look up is negative 3.89. But the idea of off the chart is not an answer, okay? We dealt with this in the video before, the previous video. How do you deal with the z-scores that are off the chart? Well, first, let me pull some concepts, some intuition in. If I'm off the chart, that means I'm way out here. See, earlier I didn't know where 48 was. Well, let me tweak my picture now. 48 must be like way out there, almost falling off my mountain, right? And it still wants more than, well, golly, I'm pretty sure there's nothing left, right? But okay, maybe that's confusing you still. You don't have the underlying concept. What can we do when something's off the chart? This is a positive 4, right? So you're going to go look up the biggest positive that you can look up, which is 3.89, and you're going to see the number 1. And the 1, remember, is representing 100%, right? Here's the problem. Students they're not as organized as me, no offense. They usually have something like this. They calculate their z-score, they look it up, and they try to tell me the answer is 1. Well, no, it's not. Does that look like the entire curve? We already decided we're supposed to have a tiny answer. That's not a tiny answer. That's the biggest answer you can get. What did I forget to do? It said more than, greater than, greater than, greater than. This z-chart gives me less than. This z-chart just gave me all of this area. So what do I have to do? I have to subtract it from 1. So it is 0, or you can say in decimal form, or 0%. The answer is approximately 0. Now, why I personally am going to use the approximate symbol, you don't have to. Here's the thing, it's probably not exactly 0. This chart only does 4 decimal places. It might be 0.0000067 or something, but to 4 decimal places, which is the limitation of this chart, the answer is 0. That looks like a peach. Hold on. 0. Okay? So that's how you can use the chart. Now, think about it. If the problem had said less than, then yeah, the answer is 1. But this was a greater than problem. Basically, now, that's how you can use the chart, even for the off-the-chart problems. But let me come at a little more intuition conceptual. If you know, because you calculated your z-score 4, that you're off the chart up here, when you're off the chart, guys, the answer is either 0 or 100%, right? And this one said more than. Well, that's not 100%. Oh, it must be 0%, right? You'll get to practice that more on handout 9. All right, let's do D. Describe the fuel efficiency of the worst 20% of cars. So it's really saying, what's the miles per gallon? It's basically asking you for X. The worst 20%, that's a probability, that's an area. It gave you the area. So this is absolutely a working backwards problem. Now, on the working backwards problems, it is so beyond critical to draw a picture. Otherwise, you got a 50-50 chance of getting it right. And I don't think anybody wants to take test 2 just getting half the problems correct. Because here's the thing. Again, students who don't want to have to think and read the word problem, you might as well flip a coin on whether you're going to get it right. You see this area of 20%, but how do we know if we're really looking for 20% or 80%? We don't until we think about the problem. So most of the thinking occurs at the beginning of this problem. All right, let's draw a picture. Now, I cannot stress enough how important it is to keep up with the variable. This is miles per gallon. That's my variable, right? And they want to talk about bad cars. So this is all you got to figure out. Are the bad cars here or are the bad cars here? Those are your only 2 choices, okay? And if that confuses you, go extreme. 5 miles per gallon, 500 miles per gallon. Where are the bad cars? Oh, yeah, 5 miles per gallon is a terrible car, right? Okay, yeah, if you're making 3 or 5 or 8 miles per gallon, you have a terrible car. This is the bad cars. 20% is 0.2. That's how you know which tail, which corner you're working with. Why do we care? As soon as I draw this, I'm like, oh, yay. This, see how that matches the picture, right? This is a less than problem. This is a less than chart. Yes, your area really is 0.2. That's an area, not a z-score. The most common mistake on test 2 is for students not to label things. They will just have a 0.2 on their paper, okay? And then they'll, within 30 seconds, think it's a z-score. They'll go look up a z-score of 0.2. That's not what that is. That is an area. Your picture is also reminding you that in a minute, you better be getting a negative z-score. And then after that, your final answer better be less than 24 miles per gallon. All right. What helps some students is anytime they know they've been given an area, they will make it 4 decimal places. I mean, you don't have to. This is just if it's helpful to you, because it helps remind them, oh yeah, the areas are in the body of the chart. This is that needle in a haystack we talked about on the previous video. I've got to look around here to find 0.2000 or as close to that as possible. Once you figure out where you are, check each neighbor to see if you can find a better one. And again, you're not going to find that precisely. We're just going as close as we can. Like suddenly I see 0.1977, but actually, so I just did this really quick. I'm going to check each neighbor. I'm like, oh, no, 0.2005 is better. So just to let you know what I ended up finding as the closest is 0.2005. Now, once I locate that, I'm going to put my finger on it. Send your hand out and up. You'll see the z-score is negative 0.84. Now, if I just confused you, hopefully I didn't because you watched the previous video, back this video up 2 minutes and listen to that again. That's my z-score. Yeah, that's right. I was supposed to have a negative z-score, right? I feel like I'm doing okay. That is not a miles per gallon. So remember, we've gone A to Z now. We still got to get to X, the exact same z-score formula. I want to just write this down here. That's my z, right? Equals. I don't know what X is. I know the mean. I know the standard deviation because that's the z-score formula, right? Z equals X minus mu over sigma. Do your algebra, solve that, and you will get 18.96 miles per gallon. I know the science majors are cringing right now that I did not put the units. But if I put the units, then I take 20 emails saying, will you take off if we don't write the units? Guys, I'm real happy if you just get the 18.96. Yes, the units are miles per gallon. I do not take off if you don't write that. All right. I have, oh no. Sorry, I thought I was towards the end. I want to do part E now. This is bringing back a word from test 1. What gas mileage represents the 3rd quartile? So first, you can tell it's asking you for X, right? So obviously, this is going to be a working backwards problem. But it's like, well, where's the area? I don't see a percent sign. What's the area? Well, this had a special definition, right? But let's first remind you of a synonym for that. I could have said what gas mileage represents the 75th percentile. Remember those synonyms? All right, 75th percentile, which means 75% is below the line. All right, hold on. I need to draw this, right? Where does the line go? The line has to go up here to have 75% below, less than the line. That's the definition of the 3rd quartile. That's the definition of the 75th percentile. Okay, so again, remember I told you all the thinking really occurs before you start number crunching. I see that I better end up with a positive z-score. I also better end up with an X value larger than 24. I like this. This is a less than problem. My chart reads less than. So yes, here's another one that I really do get to search for 0.75. It asked that. I do get to search for it. I only did that because I thought through the problem though. So again, if it makes you more comfortable, you can make it 0.7500. You're going to start to go through here and find 0.7500. That's not a z-score, that's an area, right? I'm looking all around in here. I got 0.7486, 0.7517. Let me put in parentheses what is the closest. 0.7486 is the closest. Again, pause me at any time if I'm going too fast, the beauty of the video. That looks like it is a z-score of 0.67. Positive, which I was expecting a positive z-score. Equals, I don't know what x is. I know the mean, I know the standard deviation, do the algebra. So, you know, at some point the steps become the same. It was just all the thinking at the beginning. 28.02. All right, let's do F. Keep checking to make sure my photo booth is doing okay. I went back to my old computer instead of my brand new computer. Describe the most efficient 5% of cars. So basically it's asking for the good cars, right? Similar to what we talked about, I guess, in part D or E. The good cars are up here. If you're getting 50 or 60 miles per gallon, you've got a great car. Please, please, please. A mistake that people make, too many people, on every single test in the final exam is turning that into the wrong decimal. These are my good cars. 0.05 is the appropriate percent to decimal, okay? Now again, if a student is not paying attention, if they're not being organized, well, they're going to do one of two things, and both are wrong. They're going to go look up a z-score of 0.05. That is not correct at all. They're going to go look up an area of 0.05. That is not correct at all. Your picture tells you you better have a positive z-score, and you better have an answer bigger than 24. If you go look up an area of 0.05 right now, you're going to have a negative z-score because you did it wrong. What am I talking about? This chart, see, this chart rules our life. This chart always wants to know, here's another way of saying it, who lives on the left of the fence. See how this is a fence separating that side from that side? This chart right here wants to know who lives on the left. Well, 5% lives on the right, so 95% lives on the left. What did I just do? I subtracted from 1. The area I have to use is 0.95. Why did I subtract from 1? Well, the entire thing is worth 1 or 100%, right? And this chart is a less than chart. It didn't want me to talk about how much was greater than. It wanted me to talk about how much was less than. So, again, if you like that trick of making it 4 decimal places to remind you this is not a z-score, this is an area, this is 1. You're not going to be able to find the closest because there are 2 values that are equally good. So I want to write that here. If you go search in your chart, hopefully you're going to eventually find 0.9495 and 0.9505. they are equally good, right? And if you look at the z-scores, you are going to see 1.64, 1.65. I do absolutely want you to be able to get the z-score directly in the middle. Basically, I'm just taking the average. If you want the quick and dirty way, take the small guy and put a 5 in the thousandth spot. The reason why I'm picky on this is, somewhere on test 3, you're going to see that that's probably the second most famous number in statistics, and that books do not round this to 1.64 or 1.65. They actually show all 3 decimal places there. So I'm just trying to highlight and support what I know you're going to see the rest of the semester, even from textbooks and things like that. We're not done with the problem, but I'm afraid I need to erase a little bit. So that's the z-score. So let's recap. We had an area of 0.95. So you didn't get to cheat and go look up the 5%. You had to think about it and say, oh, no, that's a greater than problem. I got to do the less than. We have this z-score. I'm just trying to recap so I can erase. Okay, and remember we said, yeah, we're supposed to have a positive z-score. Doing good. But I still need the miles per gallon. Equals, I don't know what x is, I know the mean, I know the standard deviation, do the algebra, 33.87, and that makes sense. I knew we had to have a final answer greater than 24. There is one more piece to this exact problem. If I've lost you anywhere, I probably would encourage you to back up the video and rewatch some of the stuff. A through F are what I call very direct questions. Part G is kind of a weird guy, so I wanted to practice a weird guy with you before I let you do the homework. So let me read it. If no more than 10% of all cars are to make less than 20 miles per gallon and the standard deviation is going to still stay 6, what should the new mu be? So there's a lot going on here. You know, up to this point I'd been showing you how to tell if you were given X or given A, so you would know what direction. Well, hold on. Here's an area. Granted, I don't know if it's going to be 10% or 90% yet. But here's an X. So how do you know if you're going forwards or backwards? And what's up with asking for the mu? So this is a special qualifying. They're saying, hey, we don't get to keep the same mean anymore. Maybe Congress trying to get cars, you know, more fuel efficient, whatever. They're making this a new law. The engineers got to figure out, you know, how to make the average better. Okay, so the most important thing for you to know is if you're ever given an area, that is the most critical thing. So I see I'm given an area. I know I'm going to work this as the process of working backwards. We'll figure out what to do with all that in just a minute. But as soon as you see they've given you an area, you know it's a working backwards. All right, let me get a picture. I don't even know what the mean is. That's what they're asking me for, right? The part, let's see if I can find another color. The part that I got to try to draw a picture on right now is no more than 10% are to be less than 20 miles per gallon. So no more than 10%. Hopefully everybody knows that's a little bit. Granted, I don't know if it's 9% or 7% or 3%, but a little bit, right? So I need a little bit less than 20. Where do I draw that? Well, it can't be up here because that's a whole lot. going less than? It must be here. Here's the 20. That looks like a little bit. Qualifying a little bit, 0.1. So that's my picture. I like this picture. Why do I like it? It matches my chart. It's a less than area. So, okay, yes, my area really is 0.1. That's not a z-score. That's an area. Again, if you make it 4 decimal places, that might help remind you that you are not looking up a z-score of 0.1. You are not writing 0.5398 right now. Look in the wrong spot. You are searching in the body of the chart over here for as close to 0.1000 as you can. Don't look up 0.01. This is 0.1. I'm not going to look at my notes. I'm actually going to do this from scratch. I see 0.1020, 0.1003. He looks like the closest. So I actually found 0.1003 when I looked. That gives me a z-score of negative 1.28. That makes sense that I have a negative z. Okay. So hold on though. Here's where you want to take a breath and not just go too fast. You know how up to this point we've been saying, oh, I don't know what x is, minus the mean. Wait, I do know what x is. I don't know what the mean is. See how it's really important that you know I'm plugging in for x, and it's mu that's the unknown. Think about it. This formula has 4 pieces. All I've got to do is plug in 3 of the pieces, and I can solve for the 4th one. This one is only one tiny step extra algebra than probably part E or whatever we were doing. Try that on your own right now. Make sure you know how to do it. Make sure you get a positive 27.68 as the answer. At some point you would have had a negative on both sides. Multiply both sides by -1 and you'll end up with a positive. Alright, I want to make a few more comments that are really going to be helpful to you before you go do handout 9. But in case you have forgotten what I said 42 minutes ago, and in case you printed your notes, that homework is correct. But this part that I was about to do some problems from handout 9, I don't do that as part of this video. I will do that on review day. But you should be doing all of the homework I assigned at the beginning of this video, okay? But even if you look back over the last 40 minutes, sometimes it seems that, here, maybe I should look at my notes really quick so I can, trying to find it. Yeah, like part C, we seem to subtract from 1 the very last step. Sometimes we didn't even subtract from 1, right? But part F, we seem to subtract from 1 at the very first step. So first of all, what's this subtracting from 1 thing? Well, this chart reads less than. If you ever have a more than, at least, greater than problem, you're going to have to subtract from 1. But why does it sometimes seem like it's the first step and sometimes it seems like the last step? So, because we don't always have to subtract from 1, if we need to do what I call a 1 minus problem, it will always occur at the A step. The area step. Now think about it. When you're going forwards, that means it's going to occur at the last step. If you're going backwards, that means it's going to occur at the first step. Because so again, we don't always subtract from 1, but if we're going to need to subtract from 1, I can tell you it's going to happen at the area step, because that's what 1 is. 1 represents the entire area. 1 is an area, so it makes sense that you can subtract areas from 1. You cannot subtract z's from 1. You cannot subtract x's from 1. It's always happening here. Sometimes that's the last step, sometimes that's the first step. Now, keeping up with the variable. This was important when we did z-scores on test 1. Remember how we had to figure out if something was good or bad? You couldn't just go with the positive and the negative. I spent some time on that because I knew this was coming up on test 2. So I just want to talk generically, but there are problems on handout 9 almost just like this. So making sure you understand that the variable, reading the words, you know, the actual words of the word problem, is critical. So let's say, for example, so I'm going to split this. Let's say over here the variable is words per minute. Like if we're a typist. How many words per minute can you type? I'm a terrible typist. But let's say there's a different word problem and its variable is how long did it take you to do the test? The time to do the test. Okay? Two very different variables. Now, let's say there's a problem that's asking about the fastest 7%. Okay? I want to use that same example for both, so I wrote it in the middle. Well, let's draw a picture. First of all, I just gave you an area, so we know it's a working backwards. Okay? Words per minute. Do you type 5 words per minute or 100 words per minute? 100 words per minute are the really fast, amazing people. Here are the fast people, 0.07. So on this example, you're going to have to actually start with an area of 0.93. But look at this one. Time to do the test. Time to do the test. Okay, go extreme. Did it take you 1 minute to do something or 100 minutes to do something? Oh, well, if it only took you 1 minute, you must be super fast. Here are the fast people. That is a less than. So your area really is going to be 0.07. See, when you just read fastest 7%, you have no clue whether you're going to be looking up an area of 0.93 or whether you're going to be looking up an area of 0.07. It all depends on what the variable was. So many students just want to look at that one number, and that's what I call it flipping a coin. That you're a 50-50 chance you're going to get it right. You have to take the variable and then what they're asking you. It requires both pieces. This is really going to help you, I think, on number 15 and 16 on handout 9. Before I let you go, start doing your homework, I wanted to show you a quick article. At this point, I scanned these notes in a few days ago, so I cannot remember if I scanned this article in. I think I did. This was from the Stanton newspaper, which is in Augusta County. So first of all, I'm not into rankings of colleges. They all use such different criteria that none of it is valid and reliable. So I don't normally read those articles. But this one was talking about Mary Baldwin College, which is now a university in Stanton. So, you know, I started to read it, and then I realized it wanted to talk about rankings. So then I was going to stop reading the article. But then I realized that it was mentioning JMU. So I kept reading. Now, this article, basically the ranking they were using was, we'll keep it simple, how much money should a graduate make when they get out versus how much are they making. So they were comparing salaries, I guess like expected salary versus actual salary. I was able to find the Word document on the internet site for the newspaper. So you'll see down here, let's start with it says, JMU ranks 77th out of 1275 in value. 77th out of approximately 1,300 in value. I need to make sure you know that that is saying JMU is doing good, okay? We're doing good, whether this is a valid ranking or not. We are up at the top, okay? Now, I think we've all been in an English class where there's a word count or a page count, or we need a few more sentences for a paragraph. So we kind of start to BS extra sentences, right? Just to make our paper look better. I think that's what happened here, because then this Megan Williams, I do not know her personally, she decided to try to paraphrase that in a different way. And look at what she paraphrased. JMU was in the top 94% of colleges. So then she says we're in the top 94%. Think about that. You have an understanding of this from the empirical rule we did on test 1. But if you're not catching what I'm trying to show you right now, think about when you were a senior in high school. What were you shooting for? Were you shooting to be in the top 94% of your class? Or were you shooting to be in the top 20% of your class, right? The top 94% is way down here at the bottom. That is not what she meant to say. She either could have said the top 6%, but I feel like she wanted to use the number 94. So she could have said the 94th percentile. One of those two would have been correct, but not what she said. So just something of understanding the definitions and statistics will help you be a local reporter for the newspaper. All right, make sure I haven't forgotten anything. Yes, we looked at that. You've got your homework. All right, so go do handout 9. Use my answer key if you get stuck. And we will go through more problems just so you can hear me talk it out during review days. You can also come to office hours. All right, see you soon.